Kia ora and good evening and welcome to the University of Otago Bachelor of Engineering Honours Software Engineering webinar this evening. We're very pleased you've joined us. My name is Terry Higgins. I'm from the International Marketing and Recruitment team here at the University of Otago, and I'm joined by some awesome guests, Professor Grant Dick, who is the head of the School of Computing and is going to be talking about the program today, Associate Professor Sherlock Licorice, who's also from the School of Computing, and one of our wonderful students, Shreya, is also joining us today. We do have a number of wonderful folks in the background as well. We have Alba and Cheryl from the school's liaison team. We've got Victoria from the international team and Debbie, one of our marketing advisors from the sciences. So feel free to engage with them during the webinar. The session will be recorded and a copy of the recording will be sent to registrants after the session. There is a live Q&A section at the end of the webinar, so please feel free at any time to pop your questions in the Q&A box in the Zoom webinar chat function. But there's a lot to cover today, and just giving you a sneak peek of what to expect. We're going to be diving into the nitty-gritty of this wonderful degree program, and Grant will be taking us through questions like why software engineering, particularly at Otago, some of the entry requirements and what you can expect to learn and how you'll learn. Then we'll jump over to Shreya, who will take us through her experiences as a software engineering student at Otago. We'll throw to Sherlock, who will take us through sort of career opportunities and some of the different jobs you can expect as a graduate of software engineering at Otago. And then back to me for some of the details around how to make that application as both a domestic and an international student. And then we will get to your questions. But first things first, for those of you who haven't made it down to Dunedin, welcome virtually to the University of Otago. We are New Zealand's oldest and first university, and probably most recognisable for the stunning clock tower building that you see on my screen. Fun fact, Times Higher Education recently voted us the 5th most beautiful campus in the world. So if you needed any more reasons, there's a good one for you. It's a really great place to study and just be. And academically, we are in the top 1% of universities in the world, according to QS rankings, 197, doing pretty well when you think of the number of universities around the world. We are number 1 in New Zealand for education performance, and 96% of our graduates go on to work or further study. That's a pretty phenomenal statistic. 8 of the last 12 years, we've won the Prime Minister's Supreme Award for Teaching Excellence and 5 stars plus for our international quality rating. I'm loving seeing the hearts and emojis and things coming up on the screen. It makes me feel good. And for those of you who aren't quite sure where Dunedin is, a little map of New Zealand on the right there, southeast coast of the South Island of New Zealand. These emojis are wonderful and instilling in me a confidence. So with that, I'm going to pass the mic to Professor Grant Dick, who is going to talk us through the software engineering degree program. Thanks, Grant.
Sure. Thank you very much for that. Kia ora, everybody. Welcome aboard. I am Grant Dick. I am the current head of school, or the inaugural head of school of School of Computing here at the University of Otago. The university created the School of Computing in 2023. As a merger of 2 previous departments, information science was my previous home, and computer science. And the School of Computing is now the hub for all of our computing education and research. We are currently, or in the last ranking, last PBRF round of ranking, so that's where our research performance is measured at a national level. We were ranked the #1 computing research institute in the country.
Wow, congrats.
Thank you. We continue that trend now, and we have a range of research areas in artificial intelligence, data science, visual computing and human computer interaction, and of course software engineering, which I'll talk a little bit more about now. So why study software engineering? Why not would be the answer I would normally give, but software engineering is the backbone of modern industry. There is software driving every facet of society right now, and it's not getting any less. It's not getting any smaller. Certainly, the demand for building software is getting greater. The demand on software engineers is getting greater. Even in the presence of artificial intelligence, what we're finding is that humans are actually leading the AI to develop the software, not the other way around. So despite the big headlines you may hear about AI replacing coders, what we are finding is that AI is increasingly being used to make software engineers more efficient. And so therefore, the need for more software is ever growing. The to-do list is never going to be completed. That's probably the easiest way to describe the demand for software engineering going forward. We have graduates at computing at the moment who work across a range of different roles. Some work in government sphere and non-profit. We have those who are going out to seek their fortune in finance, working in algorithmic trading and high frequency trading areas. We have people that actually move out of software engineering once they get that background and move more in towards sales and procurement. So when individuals are or when organizations are wanting to implement software systems in their organization, they often turn to software engineers to describe and help them plan out and map what that software installation will look like at a large scale. Obviously in healthcare, there's an increasing emphasis on software systems to manage our health industry, manufacturing, telecommunications, and so on. The key thing to take away from software engineering is it's not just software development. So it's not just sitting behind a keyboard and hacking away all day. There's a very large human element to software engineering, which means that there's a full complement of soft and technical skills that are required to excel in the area. I won't talk about careers right now. Sherlock will talk about careers shortly, but we'll press on with the actual Bachelor of Engineering in Software Engineering at Otago. So we're very, very excited about this. It's been nearly 2.5 years of hard work to get this underway. And we've been given the go-ahead to start our program in February 2026. So this will be the first intake of software engineering students under the Bachelor of Engineering banner. One of the key things that we're particularly pleased about is that this is a professional degree. We have developed it with the approval and accreditation of Engineering New Zealand. It is the first Engineering in New Zealand accredited degree at Otago, so we're doubly proud in that regard. But what that means is that it will be an internationally recognised degree, and it'll be recognised under the Washington Accord. So in the US, Europe, Asia Pacific areas, there will be no problems recognising a degree that comes out of Otago in those areas.
Fantastic.
So yeah, you can guarantee that you'll be recognised as a professional software engineer in those regions. A Bachelor of Engineering, particularly an honours degree in New Zealand, is 4 years of full-time study. It is significantly driven around project work and group work. In your 4th year, there is also a research project element to the work that you do. As part of the accreditation process and as part of your studies, the Bachelor of Engineering requires 800 hours of professional development. So that means work experience, internships, placements, to some degree your casual work. So if you're working part-time in the warehouse or some other retail outlet, for example, some of that can be brought through as part of your professional development as well, learning to work in a team environment and so forth. So you contribute this 800 hours across the 4 years of your degree, predominantly loaded on the 2nd, 3rd, and 4th years of your program. The one thing we're also particularly proud of is that this is Dunedin campus only, so that wonderful clock tower that you saw before, if you arrive at Otago, you'll be seeing an awful lot of it because the software engineering program is in person only. It's heavily reliant on involvement with the academics and group work, and so the only effective way to deliver this is through a campus option only.
Fantastic.
Thank you.
So what about entry requirements, Grant?
So to get into the Bachelor of Engineering honours software engineering, first and foremost, you have to have university entrance, just like any other degree at Otago. On top of that, the standard pathway into software engineering will be through completion of credits of calculus NCEA level 3. And that is the default route that Engineering NZ requires from engineering programs.
Can I just comment, we do have some international students and education consultants on the line as well. So I believe Victoria will pop into the chat the link for both the domestic and international requirements for university entrance.
Very good, cool. Yes, and obviously there are edge cases there and case-by-case examination that can be done there if it's not completely obvious how the mapping between the New Zealand curriculum and international curriculum would be. So that's to get your foot in the door to software engineering at Otago. Once you're in the program, you have also an entry requirement at second year, which is the compulsory papers that you take in first year, of which there are 6 of them, must be completed with a B average. Now, unlike other programs throughout the country, we don't place an enrollment a limit on the number of seats in the program, so it's not competitive on the grounds of a capped number of entries. The requirement is excellence through the individual with a B average. Okay, so if you work to your own capabilities and work along with the academic staff here that will guide you through that process, and you've got that B average, getting through the second year is no problem.
That's fantastic, Grant. And so if for someone who's really already thinking software engineering is for me, this is perfect because you don't have that general engineering, you go straight into software engineering.
Yes, yes. Yeah, one of the things, because software engineering at Otago is the flagship, and in fact, at this stage, the only engineering program, our engineering first year is tailored to meet the requirements of Engineering New Zealand accreditation, but also tailored towards our software engineering program itself.
Great. And applications are now open by the looks of it. So if you're a domestic student on the line applying before the 10th of December and international students on the line need that application in by the 15th of November.
Yeah. So what will you learn in a software engineering program? So obviously our goal is to make you a software engineer and more importantly, a professional software engineer, and that has a range of expectations to it. So we have to cover the theory, we have to cover the practice. So particularly starting at our first years, but obviously cemented throughout the entire program, is that idea of developing robust, secure, maintainable software, so that it can be adaptable for now and in the future. There'll be an awful lot of practical skills. Building software is not an activity in and of itself. You build software for people, so you need to understand how to align what the software will look like with the needs of what the users are actually asking for the various other commitments that that the software needs to fulfill in terms of fulfilling performance requirements, performing compliance with regards to standards and so forth. So you have to develop those skills around aligning the software lifecycle to the practical needs of the user and so forth. Software engineering, as I keep saying, is a human-centric activity, despite the name. So you have to have those key problem-solving and communication skills. You will be liaising with users and other developers. You will be working with multiple stakeholders as a software engineer. So the myth of working behind a keyboard all day and night does not exist. And you need to have that good ability to communicate and convey ideas to all stakeholders. You need to be able to understand what it means to be a professional developer. The best way to do that is through work placements. So there'll be activities in your second, third, and fourth year where you are embedded or work on projects and so forth. And that's to develop those professional skills, understand the skills that you're learning in the classroom and apply them into a more practical environment. And then finally, in your fourth year, you have a project that you will complete under the supervision of academic staff members. And this will put your foot in the door to research, which will give you the research and development skills that you'll need in industry, but also give you a foot in the door towards further study if you're like myself or Sherlock, that you'll talk in a minute, that want to continue into the academic world and become professors.
This is sounding more attractive by the day. Can you tell us a little bit more about the specific content in each year?
Yeah, certainly. So software engineering is a multidisciplinary area. So in the first year, you're learning about the foundations that you'll need and that will build upon in years 2, 3, and 4. So you'll learn about the fundamentals of computing, so programming, a little bit about computer architecture and representation and so forth. You'll learn a little bit about the ethics of computing and computing systems and how they play in society. You'll get those core math skills that are needed for the problem solving for later on. Although software engineering in itself is not a extensive and maths rigorous discipline, the foundations in maths give you the numeracy and the skills, the problem solving skills that help you excel later on. In year 2, that's where we really cement the bedrock of software development skills. So that's where we bring in algorithms and data structures, databases, user-centered design. So trying to understand the personas that you are going to be developing for. So not just the actual work environment they'll be in, but who they are, what their needs are, and how that impacts on the software development process. And we start to bring in those communication skills through group work, presentations, and that sort of thing. Year 3 is where we try to embed those skills even further in more practical projects. So we start to bring in the actual notion of building a larger scale application. That will require you to understand how to build it in terms of an architecture, so how to scaffold it in terms of its design and so forth, how to measure its quality, that it's actually fit for purpose and so forth. You'll understand a little bit more about the human computer interaction process. And then we start to bring in more concepts that now that you've got an appreciation for how to build these systems, about how they will be impacting on sustainability, for example. So we build these large-scale software systems. What is the impact on the environment in terms of the emissions they might create and in terms of their running, but also what efficiencies we can gain in terms of sustainability and so forth by bringing in these systems. And of course, there'll be a scaffold of project management because you are using projects, so developing projects. So we need to teach you the skills that allow you to manage and collaborate within those projects. And then in your final year, that's where we basically take all of these skills and bring them up to the next level. So there'll be a mixture of research elements and more project development. There will be some electives in there that you can take. So if you've got a particular interest in artificial intelligence or networking or human computer interaction, you'll be able to take those electives that allow you to specialize a little bit in those areas while still having that good general software engineering practice.
Amazing. And anyone who would like to scan the QR code on the screen, that's where you can dive deeper into some of the papers or courses that make up those different years that Grant's just outlined. So how will you learn? What does all this look like in a practical sense? So
as you saw earlier on, 8 out of the last 12 years, we've been selected by the Prime Minister for our outstanding teaching. That is representative of our wider teaching capability. And one of the things that we excel at Otago is this idea of smaller group, hands-on interactive teaching. So how will you learn? You'll learn through the traditional methods. There'll be lectures and labs that you'll attend. There'll be tutorials that you attend and that sort of thing. The labs themselves will be quite small scale. So there'll be a class size of no more than 20 students, and that would be considered a fairly typical class. Even at 100 level, those classes would be certainly no more than 30 students. At 200, 300 level, you'd definitely be seeing classes of around 20 students with a team usually of about 3 to 4 demonstrators and teaching staff in there to give you that very detailed and very interactive experience. We bring a whole lot of practical examples into the lab environment. So you're not just learning from pre-baked case studies. A lot of the work will be on a contemporary topic, an issue of the day, brought in by the academic staff to say, okay, you're going to work on a relevant issue in, said before, sustainability, or it might be an AI project, or it might be to address the need of a group from a local community or something like that.
So it sounds like some pretty close contact with some leading academics, if I know anything about our School of Computing.
Yes.
That's awesome.
Yeah, the key thing about an academic life as an academic leader in here is high number of contact hours. So we are expected as Otago staff to be in the classroom for a minimum of 5 hours per week for every paper that we're in. And so, yeah, the faces that you see in the lectures and giving the research-led teaching in those lecture environments are also the faces you'll see in the lab environment and the tutorials and so forth.
Incredible. And so for anyone on the line who's perhaps curious about the other options within the School of Computing, can you speak quickly to what we're seeing on the screen?
Absolutely. So, yes, software engineering is not the only thing we offer. And as I say, we build on a number of other programs to provide the software engineering program that we have here. If it's not your thing, there are other options. So computer science is the bread and butter of our mainstay of our teaching. So computer science is both the theory and application of computing. So not just building software, but building networks, large-scale databases, bringing in the notion of artificial intelligence, and so on. Theory of computing, so the underlying mathematics behind computing to make these computer systems work and so forth, is what's caught and it is a catch-all in that computer science program. We also share a program with the School of Business on business analytics, and you can think of that as data management, statistics, and data science embedded in the business environment. So you learn a lot about business ethics, indigenous business, and so forth, and how you actually address the data and processing needs and analytical needs for those business contexts. We have a pure data science program under the Bachelor of Science and also under the Bachelor of Arts as of 2026. And that is where you see the intersection of computing and statistics, and also an appreciation for data ethics and so forth in there. A three-year program, which if you're sort of on the fence between statistics or computing, might be a good complement of those skills.
Wonderful. And for that Bachelor of Engineering, it's the program we've been talking about tonight, where you would head, and more information under that QR code there as well. So we've heard from the man himself, and now it's time to hear from one of his students. So I'm really pleased to welcome to the panel Shreya, who is a fourth-year software engineering student here at Otago. Welcome, Shreya.
Hi, my name is Shreya, and I'm currently a fourth-year student studying software engineering and data science. And I'd like to share a little bit about my journey, what I've learned, what makes Otago amazing, and why I find this field so exciting. So I think a lot of the stereotypes when you think about software engineering is you think, oh my God, somebody is in a dark room and they're coding away. But the truth is it's a very collaborative environment. And those skills I've learned through my degree at Otago. So from my perspective, my degree was very structured. My first year, I was kind of thinking about those cool concepts of programming, databases, and maths. And as I moved into my second and my third year, and now I'm in my fourth year, we dived deeper into those areas of algorithms, software architecture, and development. One thing that I really appreciated was that emphasis on teamwork. So in my second year, we started with a software development paper, which kind of introduced us to guided group work, which helped bring those skills of collaboration and communication. Those experience that laid that foundation really helped when we came to our third and our fourth year, where we had to do more independently led projects. So one example of that is on the slide. Last year in my third year of uni, my group, we created a website called StuCal. So one of the frustrations was trying to integrate our timetables with our Google calendars.
What do you mean that's a frustration?
Definitely can be a frustration when everyone's really busy. So our website was aimed to create a dashboard where we could find free time to schedule everyone's group studies together. So through this, I was able to work with writing HTML, JavaScript, Tailwind, and use an external database called Superbase. And that real world application of doing that project kind of gave me that hands-on experience of what I would actually have to do in the real world. So this year, we've been kind of continuing learning those industry skills, such as writing technical specs, managing deadlines, and learning how to effectively work in a team. This year's group project, as on the screen, is creating a chatbot, an AI chatbot called Course Cupid, which will kind of be helping in situations like this, where we want to find out what courses fit the right person.
I love that. All of your projects have actually been really kind of functional things that could help us.
Exactly.
In our learning at Otago, which is awesome.
So one thing I'd say is our lecturers are a huge highlight. They're very approachable, passionate, and are involved with lots of different areas of research. There's a very strong student support, whether that's having labs or office hours, and those different peer groups. I believe that I've been supported a lot. Also, some other kind of things that I've experienced was having leadership opportunities. So through the uni, I was a part of the Otago Computing Student Society last year as a secretary. So we were able to have events such as a hackathon and have better social interaction with our peers, which I truly think is going to help build that alumni network after we graduate.
Is it quite common for students in the programs in the computing school to join that society?
Yes, I think last year we had a record of about 100 people in, which is huge, considering the stereotypes when it comes to computer science.
So it's one of your must-dos.
Yes, definitely. Awesome. And we've had a lot of support with that from the staff as well. And alongside this, I was actually very fortunate to have the opportunity to do summer research, where Sherlock actually was one of my supervisors, and I was able to explore racism that's prevalent in software engineering platforms such as Stack Overflow, and was able to create some large language models to detect the different types of racism. As for what's next, software engineering opens to a wide range of paths, whether that's getting into app development, cybersecurity, AI, or data science. My degree has given me those tools to go into any direction. Personally, I'm quite interested into eventually going into project management within the data science kind of sphere, helping solve meaningful problems through tech. So if anyone is considering studying software engineering at Otago, I'd say that if you're really curious and you really love problem solving, I think it could be the right degree for you.
Wow, that's awesome. Thank you so much for sharing that. I think it's great because I think Sherlock's going to be speaking to some of the potential career opportunities that a graduate like yourself could be kind of thinking about heading to. But if you had one piece of advice for someone who is in, say, year 13 at a New Zealand high school right now and sort of thinking about push and go on that application, what's one piece of advice you would have?
I think my main piece of advice is to think about longevity and what is really important in our modern day world. I think that, as Grant has already kind of addressed today, it's very obvious that software and AI and all these things are extremely important to the development of how we're going through as a society. So I think when you think about longevity of career and stuff like that, I think that there's so many opportunities within the software engineering space, and there's a lot of different ways that you can kind of take your degree and your career. I think that's something that I would think about if I was in year 13. Yeah.
Wonderful. Thank you so much for sharing that. I'm sure there's a lot of questions percolating in the heads of some of the people listening on the line today. So perhaps some questions will come your way towards the end of the webinar. But now we're going to throw over to Associate Professor Sherlock Licorice, who's going to talk to us about the different career opportunities for a graduate from the software engineering degree here at Otago. So over to you.
Oh, thank you, and welcome again. So when we speak of software engineering, we're sort of thinking about the engineering principles that guide designing, developing, testing, and maintaining software. And so there's a life cycle that we traverse to ensure that we do this systematically, securely, and effectively for end users. In this regard, careers are tied to this life cycle. So if you sort of think of the pipeline we design, and a career that is actually typically aligned with designing would be a business analyst. That person will speak with their clients, users, customers, in order to design software or plan that software that the developers then develop. So the next career in that regard are developers. That's a sort of big catchment where lots of people become web developers, mobile developers, Windows system developers, and so on. And developers typically code the software. The next career relates to testing and the quality of the software. And typically that spans the DevOps or the development operations lifecycle. So some of these testers or quality assurance engineers also configure how we actually release the software rapidly. So there are several tools and scripts that are typically a part of that pipeline that testers and quality assurance engineers typically would take care of. The next potential career along this pipeline again relates to user experience. When we develop software, we want that the software be used, and especially over an extended period of time. How do we get that done? We develop to the user's needs and their desires. Sometimes when we develop and we release software, users oftentimes may use the software as is, but have more requests. And so we grow that software and maintain that software over time, ensuring it's usable. And hence, user experience is another career that typically will help us to deliver on these promises. Beyond that, software developers can be at times managed or supervised by other practitioners, oftentimes in the project management sphere. For instance, in an agile context, that would be a Scrum Master. The Scrum Master may not develop, but the Scrum Master may help with managing and molding teams to develop effective software. So oftentimes when we speak of software development careers, it's not just coders, but rather careers that span the entire software development lifecycle, from conception and scoping right through to software release and maintenance.
So not just hiding behind the computer in the dark room.
Yeah.
So I'm curious, Sherlock, because it's probably on the minds of some of the people considering this degree, what is the kind of average graduate starting salary in New Zealand for a software engineer graduate?
Good question. So typically, having finished a software engineering degree, graduates would tend to pursue a graduate role, graduate software engineering role. And that role typically will have a starting salary in the range of $65,000 to $75,000 New Zealand dollars. However, typically those roles start for 2 years, or have a 2-year duration. So it starts and it's expected to complete it in 2 years, but most often our graduates will transition from such roles into more permanent roles, in which case their salaries can grow exponentially. So for instance, a Scrum Master earns around $200,000.
New Zealand dollars.
Yes,
yeah.
And you've heard right, $200,000 a Scrum Master. But software developer may earn in the range of $90,000 to $135,000. So if you sort of started as a graduate developer and you excelled and did well, after a year, say, you may transition into a more permanent experience role, which will allow you to earn sometimes twice that of a graduate developer role.
Wow, so Scrum Master it is. So I'm curious, we've talked a little bit about kind of the myth busting with AI and software engineering and kind of relevance. So in your mind, will there still be a need for software engineers with this rise of AI?
Not a good question. And I'm sure it's on your minds as well. So I'll address that. So generally when we speak of AI, we're speaking about a way of having systems mimic humans. So we want to sort of develop intelligent systems that actually learn and behave like we do. Now, software development can be supported by AI. And in this case, we call it AI for software engineering. And in this way, we sort of apply models to help us to speed up software development. And that is actually embraced by the industry, and it sort of helps with ensuring we're nimble and agile and we deliver rapidly. So in the context of us at Otago, we actually embrace AI for software development. On the flip side, there is also software engineering for AI, in which case what we do is that we tailor methods in software engineering to ensure we deliver secure and usable systems that are AI-based. So Shreya just actually mentioned her project. Her project currently looks at embedding AI into software development to deliver on systems that are smart. So if you sort of look at AI and what it's done for us and how it's actually revolutionizing sectors, it's no different for software engineer. So in some ways, what we do at Otago is we embed the skills that are necessary to ensure we not only use AI, we proof AI and we develop AI in a way that makes it very usable and supporting the actual process of software engineering. So it's not going away.
Wonderful. Thank you so much, Charlotte. This is fascinating. I'm sure some further questions are going to come through from the audience for you soon. But the next section is for those of us in the room not a software engineer, and that is where I come back to talk to you about how to apply some of the funding opportunities available and your accommodation options here at the University of Otago. So applications for this program are now open. You can go to the Otago webpage directly to the software engineering subject page. I think folks on the line are going to pop that into the chat, and you can hit apply now. You can literally apply straight after this webinar. You'll start your application in eVision and you'll be applying for that engineering honours first year. Again, links will be shared in the chat so you do not get lost on the Otago website. From there, you'll create an eVision account, and depending whether you're a domestic New Zealand applicant or an international applicant, there'll be some different requirements in terms of documents and things that you need to upload, but you'll be guided through that in the eVision portal. And finally, don't forget to click submit. There's a declaration you're going to need to read, and head down to the bottom of the page and make sure you submit that application. You'll receive alerts from the admissions team if any other documents or evidence are required, but generally a really straightforward process, and we expect to see those applications spiking up after this webinar. So now just a little bit about on how you might fund your course. And we do know we have a mixture of domestic New Zealand students on the line, as well as international students and education consultants. So for those of you in New Zealand, you can actually submit your scholarship application right now. In fact, the deadline for that is coming up later this week. So please get that scholarship application submitted as soon as possible. Entrance scholarships are available for full-time starting first-year degree studies. So any of those degrees at Otago, you'll be eligible for those scholarships. There are thousands of scholarships available, ranging in value, and you don't have to apply for a specific scholarship. That's the beauty. Once we at Otago receive your application, we'll consider you for all the different scholarships that might be a best match for your circumstances. So don't overthink it, just apply for a scholarship. And you'll do that in eVision. Provide as much information as you can about yourself, what you're interested in, what your goals are, your academic achievements, so we can match you up with the best possible scholarship. And I love these slides, our myth-busting slides. You don't have to apply for every scholarship separately. These scholarships are not only for top academics, and having a part-time job will not hurt your chances. So go ahead and apply for one of those great scholarships. For any international students or education consultants on the line, there are a suite of scholarships available for you. The University of Otago Global Scholarships, which you can see the different nationalities listed there. The Vice Chancellor's Scholarship for international students, which are unlimited, $10,000 off tuition. And finally, for our top achievers, the International Academic Excellence Scholarships, which is a far higher value there. So more information online about the details of those. But if you take anything away, it's apply for a scholarship. We also have, for certain nations, a variety of other funding opportunities. You can see those on the screen there if they pertain to where you're from, a variety of different national scholarship programs, US financial aid, and our Manaaki New Zealand government scholarships as well. You'll be sent this recording, so don't worry if this is seeming like a lot of information. You'll be able to pop back and review those. Now, where are you going to live when you're at Otago? That's another question. And Otago really is known for being the one really collegiate university. Controversial opinion perhaps, but we are a true residential university, and our residential colleges are a huge part of the first year experience here at Otago. We've got 14 unique different residential colleges. You can see the list there on the left, and actually the total number of beds in each of the colleges. Our colleges range in size and range in proximity to the campus, and there's really something for everyone. The important thing to note is these are all centrally or in part centrally governed and all have a really high standard of offering. They're excellent value for money. This one is really for the international students on the line, private rooms. You will never have a roommate here at Otago. Everyone gets their own private, fully furnished bedroom. Our residential colleges are fully catered, breakfast, lunch and dinner. The catering is halal and can accommodate a variety of dietary requirements. These are some things that cause stress when you're thinking about where you're going to kind of live for university. There's wonderful pastoral support processes in place. You've got the opportunity to specify if you perhaps want a female-only environment or perhaps to live in an alcohol-free zone. These are all within walking distance or a short shuttle to the university. And the best part, they've got academic tutoring in-house. So in addition to all the wonderful classroom experiences that Grant mentioned, there'll actually be tutors in your colleges as well. So, I mean, excellent value for money. And in my opinion, just a really core part of the first year experience here at Otago. So these are typically aimed for that first year new university starter. And applications for residential colleges are now open. So for any New Zealand-based students, they opened on August 1st, and you've got until the 30th of September to submit that application. And for any offshore international students, you've got slightly longer time up until the 1st of December, but we do recommend getting onto that as soon as possible to make sure you can secure your place. There's a lot of great information about our residential colleges on the website. You can kind of learn more about the personality of each of the colleges, and you'll be asked to select your top 3 choices during that application. So we've covered the program itself. We've covered funding opportunities. We've heard from Shreya. We've heard from Sherlock. We've covered a lot of really great content today, but if you do have any more questions, there are folks on the line and kind of available after the webinar that you can connect with. So with our New Zealand domestic students, you can talk to our schools liaison team. So we've got Alba and Cheryl on the line. They're based in Auckland and Wellington and will likely pop into your schools over the next few months. They're always out visiting schools across New Zealand, and they can advise even if you've already left school. So you can find out more about how to get in touch with them on the Otago Connect page. For international students, there's a great website there where you can actually see where our regional market managers, when they'll be in your country. We travel a lot. I personally look after the Americas. So if anyone from North America is on the line, I will be out with you soon. And your regional market managers or your regional contact person will be on the same Connect page if you scroll down to the international team. Right, so with that, how are we doing for time? We have about 15 minutes left, and we've had some really good questions coming in through the chat. Excuse me. So, Grant, are you ready?
Always.
We're not going to go rapid fire, but I'm definitely seeing some trends coming through here. But I think first it would be great if you, in your own words, could quickly just re-summarize the difference between software engineering, computer science, and data science. Same, but different.
I can do that. They don't look the same to me. That's probably because I deal with them on a day in, day out basis. Okay, so software engineering is the practice of building software for people. So it's interdisciplinary on project management, computer programming, and the principles around managing projects for building software and the technologies around building software. Computer science is a more generalist computing degree. There's still an element of programming and problem solving through programming, but the focus also contains elements of artificial intelligence, theory of computing, so the mathematics that underlies computing, networking, databases, and so forth. So it's more of a catch-all for if you want to become a network engineer or a database administrator or something like that, you would probably do a computer science degree. Data science is essentially the intersection between computing and statistics. So it's more about managing data to help humans make better decisions about their business or social activities.
Great, thank you. I think I've got it now. So we do have a question that's come through about machine learning. Where does that kind of fit in? And does Otago offer machine learning courses?
Yes, it does. So I teach one of them. Yes, we do have machine learning at Otago. They are primarily under the computer science banner, but if you are doing a software engineering or data science program, they are available under that program as well, typically as electives. So the software engineering program wouldn't have them as a core competency that's required in the major, but in those elective papers that you can take, there would be room to take a machine learning paper through that.
Awesome. And people are really listening because the questions are great. What about cybersecurity? I'm hearing a lot of kind of, as a non-software engineer, a lot of good buzzwords. Where does cybersecurity fit in? Do you have those opportunities at Otago?
Again, we have those as electives under the computer science banner, which would be available to software engineering students. We do not have enough papers to make a minor or something like that, but certainly enough to create a presence of expertise in your program. So we have options at 200 and 300 level, and then at 400 level as a more research-oriented pathway around cybersecurity.
Awesome. And what would a live Q&A be without more questions about AI? So the people want to know, how effectively does the current curriculum address these AI changes in modern work? You can throw to Sherlock if you wish.
I'll have a stab at this, and then maybe Sherlock can chip in. So we have a mixed range of approaches to dealing with AI in our curriculum. Obviously, there are certain environments like tests where we basically have to say AI is completely off limits. So when we're teaching programming and that sort of thing, we're really trying to get the fundamentals there. It's pretty much a no-go for AI. Mm-hmm. But once you've got those foundations right, not only do we allow AI in the classroom, in many cases we're embracing it. So as Sherlock and Shreya we're talking about in their courses, we're actually using AI to solve problems. So it would be irresponsible to then say, well, you can't use AI to solve the AI problem. So we embrace them. There's obviously learning exercises to come out of that as well, because if you're going to be using AI, you need to know the repercussions of using it. What are the strengths and weaknesses of it? What are the limitations? You need to be able to evaluate your achievements having used that AI software. So we offer a blended approach to using AI in the classroom on a needs basis.
Awesome, thank you. There have been a couple of questions come through about this idea of kind of the 800 hours work, the placements, internships. Does Otago place students in these, or is it sort of self-driven?
It's largely self-driven. So the students are expected to go and seek out these opportunities largely, but that's not, they're not completely left on their own. There is support in the within the university, within the program itself to support that. In terms of placements and internships and so forth, they are selected on a case-by-case basis. There will be opportunities to arise with industry partners and so forth, and they are essentially a competitive element within the program. So those with those students that align well with those internships when they're available get support to get to those programs.
And they're all Dunedin based?
No, they will be a mixture throughout the country. So,
cool.
So there will be Dunedin ones, but we have partners, for example, in Christchurch that we are working with to provide placements. These Also, some of these placements and internships won't necessarily run throughout the semester, throughout the normal university calendar. They might be summer jobs and some projects and that sort of thing. So there would be opportunities to do an internship or some sort of practicum in your hometown.
Cool.
If the opportunity arose.
Yeah, and finally, on kind of the internships idea, is there such a thing as a paid placement or internship? Is that on the student?
That is not that is on the actual position itself. So
Right.
certainly some of the more the competitive ones, there may be a paid option, but it's not a standard part of this. It very much differs on where the placement is. Some industries and some organisations now have an ethical practice where they can't offer internships unless they are paid, but others see it as volunteer service and that sort of thing. So it really does it is really determined on a case-by-case basis on those placements.
Great. And I guess a final question, is there a tītariti focus built at all into the degree?
It is embedded throughout various parts in the paper, as I mentioned. Every single student that does either a computer science, data science, or software engineering program will take papers that we call digital humanities, which is where we discuss the social and ethical implications, but also just the changing face of what it means to conduct business and science and so forth within the country in a tītariti focus is embedded into our papers there. Wonderful.
And actually the last question, really a comment for you about Course Cupid. So one of our careers advisors simply wanted to share, I love the idea of Course Cupid, and if Shreya ever wants to test it on high school students, we are ready.
You know what? That sounds really good.
Yes.
Come back to me in about a month and I'll be like, I'm going to go test it on some high school students.
Awesome. Well, we are coming to the top of time, and I think there have been some great questions that have come through. Grant, is there anything else you wanted to share before we end the webinar?
No, I think other than just this is a really exciting time for us because it's the first time we'll be able to offer that software engineering program. Yeah, it's a really great opportunity for students going forward. The contact details are there. If you want to contact us, please do.
Awesome. Sherlock, anything from you? Any final words?
I suppose just to emphasize that at Otago, we do feature prominently locally, nationally, and internationally as software engineers. So we do actually inform strategy, both that covers processes and practices. And so you wouldn't, you would be a part of that community joining us, where you would feature prominently in what we do in New Zealand when it relates to software engineering. So
tying it all back to your earlier point, why not is actually the true question when we're thinking about software engineering at Otago. And so with that, head off, submit your applications. Please reach out to us if you have any questions. There's an abundance of resources here at Otago and people to answer your questions. But we cannot wait to meet you, whether it's in February 2026 or beyond that. We really look forward to welcoming you to the Bachelor of Engineering Honours in Software Engineering here at Otago. So good evening, ka kite, and we'll see you soon.